Hello everybody, welcome to the tutorial for the transition piece assignment. You'll be completing this transition piece on paper, as the name suggests. I would make a guide on paper, but the paper guides don't come out nearly as well as the video guides in AutoCAD. The principle is basically the same. I'll be using circles and arcs to measure out distances. You'll be using a compass, but yeah, it's roughly the same thing. Now, I've suggested that you get an A2 sheet of paper for this assignment. So first thing I'm going to do is give myself an A2 area to make sure that everything's going to fit when you come to do yours. So let's see, full bleed A2. Right. Now I don't need... Okay, yeah, so what have we got? We've got a 10:1 scale. So these dimensions, 1300 millimeters and 1300, 800 millimeters down there. I'm going to scale those down by a factor of 10 when drawing this thing. I might just move this text. In fact, I'll move all of this drawing off the page for now, just so that I can see what I'm doing on my drawing paper. Righto, let's see, what layer should I jump on? Jump on that layer, I guess. Okay, so the first thing to do in this particular example is just to start with a third angle drawing of your chosen shape. So pretty much what's already provided there. Taking careful note that you are going to have a student number dependent drawing. Okay, so now that's in the right point there. Now the next thing to do is we need to join all of the corners on the bottom part of the shape to all of the corners on the transition in the center. So that's how the shape will appear from the top. What else do we need? We need the front view as well. So okay, now another thing that it helps to do in this exercise is to number your corners. The basic part, first part of this assignment done. Now the next thing is to start actually describing what the true length and the true shape of all of these pieces would be. I believe if I start down here, let's say I'm going to start with a line here. I'm going to define a new point as well. Define this point here as being point X. So I've got point X on both drawings now, and a line going between point 6 and X that is straight down the page. So I'm going to start with the line XA. XA is going to be a truly a line I can measure straight off the drawing because it has no height. It's got no in the bottom part of the third angle drawing it has no component of height, and in the top part it's got no component of width. So I can measure this just straight off there. It's the same in both views. So a horizontal line, 69 units long. You could probably use a ruler or something to measure that. Now the other thing I need to make, neglected until now, would be something, I don't know, let's say 140 long. These are just two lines at right angles. So I'm going to use this to sort of get a Pythagoras feel for the length of these lines without actually using Pythagoras theorem. We're going to measure a line once, mark its length on this right angle line section over here, measure another line, and you'll see what I mean when we begin. Okay, so this is the line XA. Probably a good idea also to actually label these points as you go around. That way you won't lose where you're up to. Now if I want to find the line X6, X6 has a length here. In fact, it might be easier if I do this command. It has a length up there, and it has a height over here. So what you would need to do, you could get, if you were doing this on paper, you'd get your compass onto point X, and you'd measure to point 6, and you would make, using a compass, I'm going to use a circle because it's the closest thing I've got to a compass in AutoCAD. You make that line there, and then you can take your compass, move it over to this mark, and do the same thing with the height here. I've got a height of 80. I can go from this point up to this point. move this mark, get my compass information over to here. Now, if I draw a line between the intersections of my two compass marks, you wouldn't draw a full circle, you just draw a small little mark down here. Between my compass mark down here and my compass mark up there, what I find, this line here is the true length of line x6. It's going to be longer than it appears in the bottom view, and much longer than it appears in the top view, because this is the Pythagorean sum of both of its vector values. Its length in the, I suppose, I haven't defined any terms here, but say this is x direction, and its length in the z direction. Its height and its length. Okay, now that I've got the height of that, again I can use a compass to measure its value, measure the value of that length. And if I trace my compass point back down to x, I now know this is the true length of line x6. Let's go and copy 6 onto there. And I'll probably turn this 6 the right way around so it doesn't look like an 8. Sorry, a 9. Right, so now I've got the first part of that there. From line triangle x6a, I can now use what I've already got on the drawing board to find the value of line a6. Now you might wonder, how is it that we know that that's the true value? Well, if I know that xa and x6 are at right angles to each other, as they would be in the, I suppose, the true shape of this value, in plane with the triangle BA6, we're talking about a right angle at 6xa, then I can just draw a line straight between these 2 points, having already found both of their lengths, and I find the length of line A6. We can double check that answer though, just make sure that that's actually what's going on. So if I check the length of A6 in this top view, and I'll copy this over to my point there, and then I need to get one of the dimension values from here. Now in the top view, this circle that I just created, that was measuring the x direction and the y direction, let's say the width and the depth of line A6, because in the top down view we can already see width and depth. What we can't see in the top down view is height. So that's what we need to count. When we look at this second view, we need to count the height of that shape, but you must be careful not to double count the lengths. If I counted from A to 6 in this view, then I would have counted the width, the length, I would count the height, but I would also count the length again. Double counting length would end up with giving me the wrong answer here. So I just need to take the height of this value, the height of that shape there. And confusingly enough, these circles are almost exactly the same height, so I'm going to just trim off the part of the circle I don't want. So I've only got one arc there to stop confusing me, and move this one over to here. Okay, so they're my two compass marks. Made a mark here with the compass, made a mark here with the compass. This should be the true length of line A6. 113.32, and I've got it over here as 113.32. So that's the correct method of doing this. I'm slowly building up the shape, counting the x direction, the y direction, and the z direction, not counting any of them twice. Right, so you might have guessed then that if we're going to keep counting lengths like A5, I might count A5 next, find out the length of this line. I can count its x direction, its y direction, and then I can look down at the top view, and I'm going to count the same z height. So what I might actually do is I can leave on, which was my z height. My z height was this arc down here, wasn't it? So that should be, I think, 80 units. Yep. So this is my mark for height in the z-axis. So now all I need to do is I'm going to count the x and y value of line A5, if I want to find this one next. And from here to here, that is the true length of line A5. Now again, this is where it starts to pay to have a good compass. I need to find the point between A5 and 6,5, but it's going to be difficult to locate that in terms of any true math arrangements. I don't know any of the internal angles. I don't know if this is, well, this is obviously not a right angle in there. These are all very strange angles indeed. What I can do though, if I get my compass and I measure out the true length of this line, and I'm going to start from point A. Remember that line was A5, so I'm starting from point A. If this was actually on paper, you'd probably just make a smallish arc somewhere over here. The next thing you could do is find the true length of line 5,6. The true length of line 5,6 can actually be read straight off the top view because it has no component of height change. Between point 5, which is about here, and point 6 here and point 5 over here, there's no change in height in the shape. So I can get directly this value from point 5 measured from point 6, and where these two arcs intersect, I'd make a little arc here with my compass, little arc there with my compass. Where the two arcs intersect, that is the correct location of point 5. So I'll copy point 5 into there and spin him around. Okay. So you just kind of keep going on in that fashion. All of the spacings between 4, 5, 5, 6, 3, 4, and so on, they're all going to be exactly the same. So I'll put this one down here, waiting for the next line. And all of these Z heights are going to be the same, so I can now measure the top-down length of line A4. Make sure I get the right corner. The thing to be really careful of in this assignment, especially on paper, is to make sure that you really get the needle points in the right locations and you get your true length of the lines as they should be read. I can move that over there, get the length of this line. So now I can get this length, move it from here down to here. So I'm just slowly building up the shape line by line from here to the intersection and back, and I can erase my constructions. You can leave little construction lines in because you won't have enormous circles like I do. You'll just have little arcs where you've made a mark. So that would be up to point 4. Then we can do the same thing for point 3. Move this onto here. From there to there. Patience will produce good work in this assignment. You want to make sure that you take it one step at a time. Don't overreach. Okay, what else do we need? So again, I know that this circle's going to be the same length from there to there. This intersection, back down. Alright, so now that's up to point 3. I should probably copy both of these down so I don't lose my place. 4 is there, 3 is here. It was rotation 0. Okay, now we come to the line. We need to define the triangle A3D. So this triangle, the true length of line AD can be read straight off the top-down view. It has no height. So I might just put that in first. I need this one here. Move on to point A. Then I need to find the true length of line 3D. So I'll get the X and Y values from the top view. The Z value is the same as it has been for all the other shapes. And now I can read the true length of this line. So if I put this on the intersection of 3, sorry, if I put that on the center of 3, I can run out to this intersection and back down to there. I hope it's becoming clear that when I've got a circle drawn around point A, every point on the outer edge of this circle has to have a length equal to the radius of the circle. So if the radius of the circle was 130, because I was measuring the length of line AD, which was 130, then anything that touches that point, say the true length of line 3D, this length is always going to be 130 in there. It's by definition of touching the outer point of a circle like that. So when I find this true length here, whatever its length happens to be, whatever its length happens to be there, that radius, we're going to find the true edges of this shape. So after finding point 3A and D in here, now we continue to build up the shape. So I'm going to probably skip ahead in the video a bit here, and or maybe even time lapse or something, and you'll see the shape slowly coming together. I might need to reposition it on the page as well, but you'll have to pick your page position more carefully so as to avoid that. Okay, so now the shape is just about done. You can see I've had to move it over from where it started. When I'm finished with this drawing, I'll try and explain a bit more about where the best place to position the shape would be, or best place to lay the shape out. The last thing we've got to do is complete the line from B to X, the triangle BX6. So we can again read the length of BX straight off the board. We've got 61 there from B. And what else do we know? We can find the length, the true length of B6. That's not really a problem. Oh, I've already got B6 on there, don't I? Ah, no. So I need now the true length of line X6. So then I can go from 6 to X and B to X and complete the drawing. Now the true length of X6 we actually already have. We have one length of X6 down here, so you don't need to find it again. I can move this line X6 up to here, and the intersection of these 2 points, make sure it's actually intersection, yep, should be the correct shape. Now, so one of the checks we can do, the side length, the total length from B to A should be 130. So what have I got here? I've got 61 plus 69 is going to be 130. So that's one check I can make and be certain of. The other points seem to be reasonably well in place. Right, so a couple of other checks. I mean, you could double check the shape. It's probably a good idea to double check it as you go along, rather than trying to check things all at the end, because if I notice that I've made a mistake back here at D2, the nature of this exercise would mean that I'd have to redo everything after D2, all of this stuff up here. So you probably want to, as you're going through, double check each shape. Check that A5 is fine before moving on to A4, and then before moving on to A3, and so on. But anyway, that's the basic shape. You will need to at least have the capacity in theory to glue this thing together. So I'm going to put a glue tab on the end there. This would just stick between these 2 points. In fact, that might not even be a sharp enough point. It's probably better. So yeah, I could then glue this end of the shape onto that end of the shape. After you've finished this piece of work, what you should do is photocopy it. So photocopy your completed shape, then cut out the completed shape, fold up the edges, and submit it for marking. What I'll be looking for is a shape that comes out to be looking quite flat on top, flat on the bottom, and has the correct location. So if you can show that you're able to do that, I'll see that the shape is described as it should be. But yeah, that's pretty much it for this task. I mean, it's a time-consuming task, but there aren't really many other ways to do this kind of thing. And as I was trying to illustrate with the assignment text, it's actually quite practical. If you need to produce this sort of thing out of steel, or probably steel is all you're really going to work with, maybe plastic, I guess, in future. But you're able to make a component that you can't really make any other way. It's a transitioning from one shape to another, and you can get as complicated or as simple as you like on the top and bottom shapes, and as long as you've got the understanding of this basic method, the understanding of measuring true length off a diagram, there's no two parts that you can't transition between. So I hope that video has been helpful, and I wish you the best of luck in the assignment. How would be it, before I close this off, I wonder if there's a better way to arrange this stuff. So if I put this down here, then I could put this up there. Yeah, but then you wouldn't really know. Where else could I put it? Perhaps if we started flat. Nah, that's not really going to be helpful, I don't think. Oh, actually, yeah, that might be. Okay, yeah, I think perhaps if you start with the AX along there and fold it out this way, you're unlikely to run out of space that way. Yeah, look, perhaps even get an A1 sheet if you're worried about it fitting. Yeah, in general, I don't think the assignment is too difficult. I think it's a very practical concept, and I wish you the best of luck with it. Thanks for watching.